Combining radical expressions. Lesson 7.6. You're watching this video with Ms.Y Cavazos. So in this video, we're going to practice how to combine, and remember, combining means to add or subtract radicals. In the previous video, we simplified radicals. Now we're going to combine them. I'm going to give you two, and we're going to figure out, can I add them, can I subtract them, what can I do? So when two radicals have the same index and the same radicand, that is very important, same radicand, same index, then they're called like radicals, kind of like terms. The plural pronunciation for index is indices. Now you might have forgotten that the index is the little tiny number that you see here. That is what we call the index. And the radicand is the number that we have inside the radical symbol. Radicand. So, if two radicals have these two things in common, or identical, then they're like radicals. For example, square root of 14 and square root of 14. You stop and think, okay, same index, check. Same index, check. So we can say that these are like terms, but since we're working with radicals, we call it like radicals. Next example, we have square root of 3 and square root of 2. Now they do have the same index, check. There is an invisible 3 there. However, they do not have the same radicand, which is very important. So these are unlike radicals. Next problem we have 2 square root of 5 and 8 square root of 5. If we look here, same index. There should be an invisible 2 there. Same radicand. You're probably thinking, yes, miss, but it has an 8 and this one has a 2. Those are coefficients, and that's okay. These are still like radicals. This next problem, we have 7 square root of 2 and 7 square root of 6. Square root, notice I said square root for both because they have the same index. But the radicands are different, so these are not like radicals, these are unlike radicals. So if I asked you to add them or subtract them, you wouldn't be able to. Your calculator can do it, but us algebraically by hand, we cannot. So we don't mess with those. How do we add and subtract radical expressions? Again, what we need to look for is, are the indices the same? The index, do they have identical indices? Next, we pay attention to the radicand. Are they identical? If they're not identical, can we simplify? So somehow they end up with same radicands. If you're able to do that, then we can go ahead and combine what we can. So we're going to check what has identical indices and identical radicands. In this case, these two would be able to get combined. So we decide, okay, those two are going to be together. Then we go ahead and add or subtract what we need to. So let's practice some of these problems. So let's say we had 7 square root of 3 plus square root of 3. So we think, okay, same radicand, check. Indices are identical. They both have a 2, even though clearly they're not there. We should know by now that they should be there. They're there. So what we can do is, if this is what they have in common, in our final answer, that is what they're going to have in common. We focus on the coefficients, the numbers that are outside of the radical. So this has a 7 outside, yet this one, you see no number there. So what can we do about that? Treat it like, pretend this was 7x plus pretend this was x. What value can we put there so we can combine? A 1. So then we would be able to add 7 plus 1. Same idea. If we put a 1 here, then we are able to say, okay, then we're gonna focus on 7 plus 1, which gives us 8. So our final answer would be this 8 square root of 3. Next problem, here we have 14 square root of 5 minus 9 square root of 5. So we'd make our quick check. Okay, indices, yes, same. Radicands, yep, they're the same, so we can combine. So we're going to focus on 14 minus 9. And since both of these have square root of 5, our answer is going to have square root of 5. 14 minus 9 would give us 5, so our answer is 5 square root of 5. Do not add the radicals and say, oh, that's 10, or 5 minus 5 is 0. No, this is what they have in common, so our answer has to include that thing that they have in common. Next, here we have 10 square root of 2 plus 3 square root of 7. They have the same indices, but they do not have the same radicand. So, what we do with this problem is simply state that we cannot combine. Our calculators can do this. Us, algebraically, we cannot do it. So there's nothing we can do about that problem. Next, we have 6 square root of x minus 8 square root of x. Notice I'm saying square root for both of them because they have the same indices. Radicands are also the same. Even though this time they're variables, that is perfectly fine. So that means we're going to focus on the 6 and the 8. So that becomes 6 minus 8. And since square root of x is what they have in common, well, our answer is going to have a square root of x. 6 minus 8 gives us a negative 2, so we put a negative 2 in the front. That is our coefficient. And this is our final answer. We simplified. We combined. Next, in this problem, we have we have the cube root of 6 plus 14 cube root of 6. Different root, different index. But they're the same on both, so that's fine. 6 and 6, perfect. They're the same. So we can go ahead and combine. So, our final answer should have a cube root. So let me rewrite this. There should be a tiny 3 there of 6. This first number here has a 1. So what we're going to do is we're going to combine the 1 with the 14, which will give us a 15 cube root of 6, and that is how we would write our simplified answer. This next one, by now you should have caught on that, okay, same indices, perfect, same radicands. This has a 1, so I'm going to go ahead and add. So this 6 plus 1 is going to give us a 7 square root of negative 1. You're not wrong, but here our answer would be no real solution. When the radicand is negative, no real solution. Okay, in this next problem, we have 2 radical numbers, and you notice right away that, okay, one has a radicand of 2, the other one radicand of 18. They're not the same, miss. You're right, they're not. But if we look closely at the 18, you got to stop and think. Can I simplify? Well, let's see. Square root of 18 can be broken down by 9 and 3. Nope, 9 and 2. Sorry about that. 9 can be broken into 3 and 3. And these would be all the prime factors. And we have a pair of 3. So that means that we would rewrite square root of 18 as 3 goes outside. 2 had no pair, so that goes inside. So I'm going to rewrite this expression for square root of 2 plus square root of 18 is now this. So this is going to go in place of 18, square root of 18. So 3 square root of 2. By doing that, now we have that, guess what? radicands are identical, so we can go ahead and add. 4 plus 3 would give us a 7. So in your mind, you should be able to do 7 square root of 2, add the 4 and the 3, and this would be our simplified answer. Next problem here, 7 square root of 6 minus 14 square root of 24, same indices, different radicands. So this same question should be for that. Can we simplify the square root of 24? So I'm going to go ahead and on the side, square root of 24. Let's see. We can do 6 and 4, 2 and 2, 2 and 3. We must put them in pairs. Here's a pair, not a pair. So our simplified answer for square root of 24 would be 2 square root of 6, because we would need to multiply these two. So we have that 7 square root of 6 minus, now notice that there is a coefficient in front of square root of 24, so it has to go there. Square root of 24 has been transformed to 2 square root of 6, and we apply our mathematical operations, which is multiply those two, 14 times 2, and that would give us 28 square root of 6, and that is a negative, bring down the minus, 7 square root of 6. Now they have the same radicand, so now we have no problem with combining them. So 7 minus 28 would give us a negative 21 square root of 6, because that's what they had in common, so that's what our answer has to have. Doable. Okay. This problem says find the perimeter for each triangle. Perimeter means add up all the sides. So we're going to have to add this plus this plus this. But start thinking, okay, if I'm going to add them, I need to be able to have the same radicand, which we don't. So we should already think, okay, 8 square root of 28. Can 28 be simplified, or can the square root of 28 be simplified? And so we get 4 and 7. 4 can be simplified into 2 and 2. We found our two pairs. So we would have 2 square root of 7. But do not forget that square root of 28 has a coefficient in front. So I'm going to bring that number down, 8. So we multiply these two, and that finally gives us 16 square root of 7. So this is now 16 square root of 7. And if you notice, oh, same radicands, perfect. Now let's look at the 2 square root of 63. So 2 square root of 63. We're going to focus on the square root of 63. So I'm going to put parentheses around it. And we're going to simplify. So 63, we have 9 and 7. 9 can be broken down with 3 and 3. We found our pairs, perfect. These two go together. So then we have 3 square root of 7, because 7 did not have a pair. But don't forget that square root of 63 had a coefficient of 2. So I need to bring down that 2. I'm going to multiply. So this is now 6 square root of 7. So this is 6, square root of 7. Now we can go ahead and add all of these up. So 16 square root of 7 plus 3 square root of 7 plus 2 square, 6 square root of 7. Well, we would be able to do 16 plus 3 plus 6, focus on that, and our answer should have square root of 7, and we get 25 square root of 7, and that would be our final answer. We have another triangle. Again, perimeter is just adding up all the sides, but if you notice, square root of 8, square root of 45, 10 square root of 2, none of them have the same radicand, so we got to stop and think, okay, can we simplify square root of 8? So square root of 8, we use the factor tree, and we get 4 and 2. 4 can be factored by 2 and 2. We circle our pairs. Okay. What had a pair goes outside. What didn't get a pair goes inside. So we get that square root of 8 can be simplified to 2 square root of 2. 45. Square root of 45. Can we simplify? Sure we can. This gives us 9 and 5. 9 gives us 3 and 3. We found our pair of 3's. So we rewrite 3 square root of 5. So we know that this is simplified now to 3 square root of 5. Okay. We simplified what we could, and we notice that this and these two are like radicals. So I'm going to write them next to each other. Then we have 3 square root of 5. What we can do is combine these two, and that will give us a 12 square root of 2. Nothing we can do about this one, so we just bring it down. We cannot combine. This is as far as we go with this problem, and that's when we stop. I hope this helped you. Thank you for watching.